Chapter 6.6, Day 2, we're going to solve logarithmic equations. The logarithmic equations are equations that involve logarithms of variable expressions. So just like we have the property of equality for exponential equations, we have the same thing for log equations. So if b, x, and y are positive real numbers with b not equal to 1, then log base b of x equals log base b of y, and that's true if and only if x equals y. So notice you're just taking the x and the y and you're setting them equal to each other. So the bases must be the same. So if log base 2 of x equals log base 2 of 7, then you can just write x equals 7. You just set them equal to each other. So log base 2 of x equals log base 2 of 7. This property implies that if you're given an equation x equals y, then you can exponentiate each side to obtain an equation of this form, b to the x equals b to the y. And this is useful for solving some logarithmic equations. So let's try example 3. So we have natural log of 4x minus 7 equals natural log of x plus 5. So because of the property of equality for logarithmic equations, that means that we can just set what this is here equal to each other. So just drop these natural logs. You can just rewrite it as 4x minus 7 equals x plus 5. And now we're solving for a linear equation. So add 7 to both sides. We combine like terms. You get 4x equals x plus 12. Then to continue solving for x, let's subtract x from both sides. So we get 3x equals 12 divided by 3. So x equals 4. So what we want to do, though, is check for extraneous solutions. Now, the one rule is that you cannot have negative logarithms, okay? So it cannot be negative in here when you plug it in. So what we're going to do is plug in 4 into the original. So let's plug it into the original here. So natural log of 4x minus 7 equals natural log of x plus 5. So let's plug in this 4 wherever we see x. So this is going to be natural log of 4 and then times 4 minus 7. Does that equal the natural log of 4 plus 5? So we want to see if this is true. So this is natural log 4 times 4 of 16 minus 7 equals natural log of 9. 16 minus 7 is 9, so natural log of 9 does equal natural log of 9. So therefore, x equals 4 is a correct answer. Let's try another equation here. Now, if both sides are not the same, so notice we don't have log on both sides. What we're going to have to do is exponentiate both sides in order to get rid of the logarithm. So we're using this property here. If you remember, b raised to the log base b of x. What that means is this goes away and now it's just x, right? It's our inverse property. So we want to do the same thing with this log base 2 of 5x minus 17 equals 3. So I'm going to rewrite it here. Log base 2 times 5x minus 17 equals 3. Now in order to cancel this log base 2, we're going to exponentiate both sides. So now it looks like this form here, and so we can cancel out this 2 log base 2, and then just remember that these are all, what happened to these ones is these are all now in the exponent position, right? But except for this one, it drops down. So what this left side becomes is 5x minus 17, and then we have 2 to the 3rd power. And so sometimes what I like doing is writing this like this to remind myself that that 3 is the exponent, okay? So a lot of times students multiply it or they do something else different with it, not remembering that it's an exponent. So now let's finish solving for x. See, the log canceled out. So now we have no more logs, so 5x minus 17. 2 cubed is 2 times 2 times 2, which is 8. So add 17 to both sides. We get 5x equals 25 divided by 5. So x equals 5. So we want to make sure that there are no extraneous solutions, no negative logarithms. So we plug it in into the original. So log base 2 of 5 times 5 minus 17, does that equal 3? So this is log base 2 of 25 minus 17. Does that equal 3? So 25 minus 17 is 8. And then, so just evaluating this on this side. So this is a good reminder. 2 to what power equals 8? And so that is 3. So therefore, this is true. 3 does equal 3. Therefore, x equals 5 is our solution. So try these two examples here. So number 5 and number 6. Number 5 is just like the one on the left, and then number 6 is just like the one on the top. So try these two. So trying this out, number 5, you should have gotten x equals 3. So you just set the 7x minus 4 equal to 2x plus 11. We're using the property of equality for log equations. That's why we can set them equal to each other. Then you solve for x equals 3. When you plug it in, natural log of 17 does equal natural log of 17. For number 6, so you don't have logs on both sides or natural log on both sides. To get rid of it, you exponentiate both sides with the base of 10. So notice I did that here with a base of 2, then that cancels out this log of 2 here. And now just x minus 6 equals 2 to the 5th power, and 2 to the 5th power is 32. Then you solve for x, you add 6 to both sides, you get x equals 38. And then you plug it in here, and then you do find that it is true, 5 equals 5.